A million is 6 zeros, like so. So it's 1,000 times a million, right? So I'm going to get 1 billion. 1 billion is 1,000 times a million. Would you agree with that? Now, what is 1,000 times a million? So we get 1,000 and we multiply it by 1 and 6 zeros for a million. 1, 2, 3, 4, 5, 6. That is 1 billion. Everybody cool with that? But then you have to multiply by 165. Now, it does it for me. 1.65 by 10 to the power of 11. Now, now you can also put your calculator into science mode, which would be shift setup science for 7, and then it gives you everything in science mode. Even if you were to put down 560, it gives you 560 in science mode as well. So you could try it that way if you wanted as well. To change it back, shift setup normal 1. All right, now we're actually going to get to the actual area and volume part of this question. So each sphere you see there has a diameter of 18. This means they have a radius of 9. That went for 5 marks, turning the diameter into a radius. Find the volume of each sphere correct to 2 decimal places. That's also a gimme. So what are we going to change it to? Pi over 3, pi r cubed. So when one of you gives me that answer, that'd be awesome. To 2 decimal places, please. Excellent. 3053.63. It doesn't tell you to use any specific pi value, so you're going to use your thing there, and then power 3. Yeah, 972 pi, and what you said. Yeah, 3053.63. What units, Matthew? Yeah, why is it cubed? Volume, and squared for surface area. Everybody got that down? We're good? So you got to change. So you guys have a quick look at C while you're waiting on me. 9 spheres, aren't we? So what's the surface area of one sphere? 4 pi r squared. Multiply that by 9. 9 multiplied by pi, 4 pi multiplied. What's the radius again? 9. All of that. I think it's 729 pi, which should change into whatever you tell me in a second. The question this year wasn't that tough, actually, to be fair to it. It's a nice enough question. Actually, I got that wrong. 2916 pi. 2916 pi. And then press the change button. 9,161. Sphere. The surface area of a sphere formula is 4 pi r squared. That's the surface area of one sphere. Everybody cool with that? So that's one sphere. I have 9 of them. That's why I'm multiplying by 9. The radius is also 9, just by fluke. Okay, designed the question. Everybody cool with that? All right. Now, is there a D? Oh, crap. All right. Each of the 8 cylindrical pipes, they see 8 cylindrical pipes. Let me see. 1, 2, 3, 4, 5, 6. Do I see more than that? Yeah. There might be different sizes, maybe, is what they're talking about there. Each of the 8 cylindrical pipes extending from the center sphere. They're just talking about the center sphere, not the outside ones. Is that right? Has radius 1.65 and length 23. Find the sum of the curved surface area of all 8 pipes. Curved surface area only. So what's the curved surface area of a pipe? 2 pi r h. And what are you going to multiply your answer by? 8 of them. Off you go. lob it all into the calculator. You should be good to go. It says 1.65, I believe, in the question. So 23 then. Does it want it in terms of pi or nearest meter squared? What do you reckon? 1908? Yeah, great. The other 12 cylindrical pipes connect the outer spheres to each other. Each pipe has a radius of 1.45. If all 12 pipes are equal in length, find the sum of the curved surface area of the 12 pipes. Oh, sorry. The curved surface area of all 12 pipes is 3,170 meters squared. Find the length of one pipe. Okay, I think I get you. Right. We have the eight central pipes. Would everybody agree with that? How much are the 8 central pipes worth? 1,908. You then have the 12, what we call them, outer pipes. Is that okay? And we don't know how much the 12 outer pipes are worth, do we? But we know the grand total is 3,170. Why don't we get 3,170 and take away 1,908 to find out how much the 12 outer pipes are worth? So we want to do that now. The 8 central pipes plus the 12 outer pipes is worth 3,170 meters squared. So 12 outer pipes is worth how much? 1262. My next piece of advice is to divide that by 12 to find out the curved surface area of one outer pipe. So we divide this by 12 and we get 105.16. 0.16 reoccurring. So 666, which would be 105.17. Okay. Not yet though. The answer is to the nearest meter. So you keep it in decimals until you get to the answer. Then you round off. Does everyone understand that mistake? Don't round off until you have the answer. Okay. Now, what does it say? Am I going to use volume formula or curved surface area formula? Have to use curved surface area formula. Okay. It states that every pipe we use has the same radius, doesn't it? So what's the radius of each pipe then? Yeah. Are we looking for the radius or the length of the pipe in the question? It says it should be the last thing the question asks you for. Huh? Length. Okay. So what we're going to say here is that it's usually 2 pi r h, but in this case, h is the length. Do you get what I'm saying? So it's going to be 2 pi, what's the radius? 1.45 times h equals your 105.167. What do I do with the 2 pi and 1.45? They're multiplication on the left. What does that mean? Division on the right. So what do we get then? 2 pi times 1.45 into the calculator with it. That was a decently tough question in the end. $11.54. Round off to nearest meter. 12 meters. Okay. And unfortunately now we got to add the 20 pipes and the 9 spheres. Oh, that's great. The 20 pipes is 3,170. How much were the 9 spheres? I think that was the answer to, was it 1? Add them together and what you get? 1262. What? 4432 meters squared. Now, it costs €70 per meter squared, so we're going to have to multiply this by 70 and convert it into money. 310. Now, guys, if you're in a test, would everybody agree that that question's easy? Would you agree with that? But getting an answer to using that question is difficult, yeah? You could make up an answer. You just lob your answer into the previous question, make up an answer, and do that question anyway. Do you get what I'm saying? They had to give you marks for correct technique. So you shouldn't leave a question like that blank. Imagine you couldn't do any of the rest of it. Just lob in an answer and do the correct technique, and you should get something out of it. Yes? Sorry? Oh, is it? Oh, 9161. Sorry, guys. It was actually at the very beginning, wasn't it? There it is there. The 9161 was the answer of part C. So we go back here. So add the two of them together, and what you get, Matt? Is it 12,331? And multiply that by 70. It's an expensive ornament, this, or expensive sculpture. 170. Yeah, there you go. It's expensive. Move on, next one. All right, let's keep going. All right, awesome. A company has a spherical storage tank. The diameter is 12. What's the radius? Okay, what's the volume? We'll move a bit quicker through this one. 5/3 pi times 6 cubed, anybody? (288 pi), and can you convert that into nearest meter squared for me? 1905 meters cubed, because it's volume. Oh, sorry, 905, not 1905. Okay. Okay, let's keep going. Let's get the pace up a bit here. The company paints the outside curved surface of the spherical tank. Calculate the curved surface area of the tank, correct to one decimal place. Yes? Yeah. What's the curved surface area of a sphere? Okay, you see this is starting to get repetitive now, isn't it? 4 pi times 6 squared. Lob it into the calculator, let me know what you get. 45? 452.4 meters squared. Right, this is easy money at the moment. Okay, very easy money. Now, can I move on? Yeah. Okay, next one. The curved surface is painted with a special paint. 1 litre of paint will cost 3.5 meters squared. How many litres of paint are used? Correct to the nearest litre. Now this is hassle here, okay? What's the area again? 452.4. All right. Now here's the problem. 452.4 meters squared. How many 3.5s are contained within that? All right. So divide them into each other, and you need 129.26 liters. Is that right? Now, you need over 129.26. You can't round that down. Why can you not round it down? Because you'll have a bit left over with no paint on it. Okay, you need exactly 129.26. Okay, it's sold in 25 litre tins. So what does that mean? 25, 50, 75, 100. 125 won't do the trick. We need 150 litres, which is how many cans? 6 cans. So multiply 6 by 180 and you're good to go. Here? Yeah, sorry, yeah, the working should be, those working should be down here. You're right. So 1080. Okay, flying. Okay, let's keep going. The next one is at another site, the company has a different shaped tank with the same volume. So same volume means what? What's the volume of the initial one, the cylinder one? The sphere one. What's the volume? Go back a question. Read me out the answer. What's the volume of the sphere we got? 905. There we go. So what I'm stating here is that one hemisphere plus another hemisphere. What's a hemisphere plus a hemisphere? Plus a sphere. A sphere plus a cylinder will equal, it's a terrible cylinder. Anyways, a sphere plus a cylinder will equal 905 meters cubed. How did I know that? Same volume. Okay. Radius of each hemispherical end is 4.5. Now we can do this for volume. What's the volume of the sphere? Or you could have done the two hemispheres separately if you really wanted. I don't see the point in doing the two hemispheres separately. Does that make sense? Yes. What's the radius? 4.5. While we're doing this, what is the point of the question? What does it want from me? What does it actually want from me? It wants the height of the, it wants the volume of one of the hemispherical ends. Sorry, I'm jumping the gun here. I'm actually doing the next question already. So in that case, we actually do have to use 2 over 3 pi 4.5 cubed. My fault. You could divide the answer by 2 at the end if you want. So what do we get? So let's change that into 2 over 3. And then change that into 4.5. And what you said was 191, yeah? Okay, grand. Now, you'll see the next part is what I was doing already. I jumped the gun. Find the H value, isn't it? So that's one hemisphere plus your cylinder plus the other hemisphere. We know that each hemisphere is 191 each, don't we? And we know the answer is 905. What's the formula for the cylinder? Pi r squared h, okay? And what's r squared in this case? There we agree with 4.5. In the previous question, it stated that the new tank is the same size as the old tank. So the two hemispheres plus the cylinder that makes up the new tank has to be the same size as the old tank, which is 905. You're ahead of me, James. Yes, that's exactly what we're going to do. So you get your 905 and you take away your 191s. Take away both 191s and you're going to be left with 523. The cylindrical end is 523. Now what do we do with the pi and the 4.5 squared? It's multiplication on the left. So what are we going to do with it? Division on the right all day long. Forgot the pi, didn't I? 8.22. Correct to one decimal place. 8.2 meters. We good? Awesome. Right, let's keep going. All right, I'm going to skip this one. Can anybody tell me why I'm going to skip it? It's pretty much what you've been doing all along. So you guys are going to try it on the weekend on your own. I think you can do that, no bother. I'm more interested in doing something a bit different here, okay? So this one here. Now, this one here. All right, let's figure this out. What happens if I do Oh, there's two ways of doing this. Can anybody tell me the two ways of doing this? You can do the big square, which is going to be the big square is going to be 7 by 7. Would you agree with that? And what's 7 by 7? 49. What's the size of every triangle? 2 by 5. Would you agree with that? And what's the area of a triangle? Area of a triangle is a half base times height, only because they're right angled triangles. Would you agree with that? So what's a half 5 times 2? Half 5 times 2? Half of 10? 5. See all the triangles? They're worth 5 each. So what happens when you add all the triangles together? You get 20. 49 take away 20? 29 meters squared. There is a second way of doing it. Some of you guys might have done Pythagoras' theorem. You would have done this length is 5, this length is 2. You would have got the hypotenuse. The hypotenuse would have turned out to be root 29. Then root 29 by root 29, when you multiply length by width, will give you, what's root 29 multiplied by root 29? The answer is 29. That's if you want to get the area of the square directly. You have two choices, okay? Either choice will do it. Do Pythagoras' theorem to find out what is the length of one side, and then you know that all 4 sides have to be the same because it's a square. Okay, move on. All right, the second part's a bit more difficult. Okay, now 2 circles, and the circles U and V represent 2 wheels that are free to rotate about their centers as shown. The radius of U is 4 and the radius of V is 6. Find the circumference of each circle. What's the circumference of a circle? 2 pi r. Leave it in terms of pi. So one of them's 2 pi times 4 and the other one's 2 pi times 6. Respectively speaking, they are 8 pi and anybody else? 12 pi. Now, I'm going to show you a little trick here, hoping it'll work. Okay, I'm about to do a circle here. This is a visual. Okay, see the way I did 2 circles there? Okay, now what my plan is to, oh wait, give me a sec. All right, blue one here, called the red dot here. Okay, and my plan, if I can pull this off, I'm hoping I can. Okay, what I'm going to do is I'm going to rotate this. I'm hoping that I can rotate it. I'm going to rotate it so it's in contact with the other one. Now see the way the blue and the red dot are in contact with each other right now. Now, as the blue one rotates, the red one also has to rotate. Would you agree with that? When the blue one does a full circle, the red one won't be able to complete a full circle. Would you agree with that? It's too large. So the red one will only be, it won't be near completing a full circle. Does that make sense? Yeah. So the blue one rotates every 8 pi. So the blue one is 8 pi, what's it, 16 pi, 24 pi, 32 pi, 40 pi, and 48 pi. Would you agree? That's how many times, that's the distance it covers with each lap. Would you agree with that? Now what about the red one? What was its size? 12 pi. 12 pi, 24 pi. At the end of the red one's second lap, it meets the blue one at the end of its third lap. Does everybody get that? Brilliant. All right, that's the hardest part, I believe. If U and V are non-slip contact and therefore one rotation causes the other one to rotate, Find the number of complete rotations wheel U makes if wheel V completes 100 rotations. Which one's V again? The smaller or the big one? Big one. What's 12 pi times 100? 12,000 pi. Divide 12,000 pi by 8 pi. We're expecting the smaller wheel to do more rotations than 100, aren't we? So divided by 8 pi, and we get 150 pi. Is that cool with you guys? All right. Is that the end of the question? Oh, thank God. Yeah. You guys finish the rest of that. You have your